So looking at part C of question 8, the question is, I've been away for a little while, so we're looking at when the particle reverses direction, and that occurs when the velocity changes. So if you think a positive velocity is to the right, a negative velocity is to the left, the only way to change direction is go from positive to negative through zero. If you can draw the sine function on your graphics calculator, but it's quite handy if you can sketch the sine function, knowing that when it's 0 radians, sine t is 0, and that the 2 in front of sine t is going to double the amplitude. So the basic sine graph plus 1 minus 1, so double it will go amplitude up to 2 minus 2. So that will equal naught at the places it always has, 0, pi and 2 pi. And I'll just reread the question. Find the times when the particle reverses, and it gives a restricted domain of 0 less than equal to t less than equal to 2t, 2 pi. And just be aware that it could have done a domain up to, say, 4 pi, and then you would continue that periodic pattern, all right, to 3 pi, 4 pi. So the ones written down here are the times. So when time is 0 radians, pi radians, or 2 pi radians, the velocity equals 0. And then you'll need a sine diagram. So if you look at the velocity graph, and so remember the velocity graph was 2 sine t, so I should name that 2 sine t, then it has a positive slope. At 0. Just before 0, so just before pi, it's a negative slope. Just after pi, we're not after slope, we're after the value of the function. So before pi, the function is positive, so it's above the x-axis. After pi, the function has a value that is negative. So the sine diagram is positive, negative, and then after 2 pi, it becomes positive. And we've got to find the position of the particle at these times. So just make sure you've got the right, that you're using the position formula. So position is, the formula was, I've just got to check it out. So we want the position at 0, which we worked out in part A. So you can write it down, it's -1. And there's a couple of things. If you've drawn the function on your calculator, you can do this trace G-solve. Now I did it on Desmos, so I'm just using my calculator to calculate it individually. So 1 minus 2 cos of pi is 3. And the last one was the position at 2 pi, which I'm actually expecting to be -1 without even doing the calculation. And so that's just confirmed that it's -1.